So I already say welcome to the participants who already joined us. Hello. And we are still waiting 2 more minutes to have other participants joining us. Okay, perfect. I think we can start. Welcome to today's webinar, Europe's Power Surplus, a Wasted Opportunity. Power surpluses. At first glance, we deem them positive because what can be better than to have more energy than we need? During the first times of the Russian war and the related energy crisis, we would have dreamt of being in such a situation. I think we can all agree on that. But in fact, the situation of having more energy puts Europe in another position because the more renewable energy we have, the more is likely to be wasted. How the surplus energy can be used efficiently and what thermal energy storage has to do with that is the topic of today's webinar. Before I go deeper into welcoming our guest, I would like to introduce myself. I am Isabel Reinhardt, event manager at eWorld, and I really look forward to guide you through today's webinar. Let me give you a short technical note. At any time during the presentation, you can ask your questions via the chat or the Q&A button. It's below here in the navigation. Furthermore, today's presentation slides will be available afterwards on the event page. With that, I would like to introduce our today's guest. It is Simon Valamo. He is Chief Financial Officer at Kyoto Group in Oslo, and he is absolutely the right person when talking about efficiency and investments in our energy future. Welcome, Simon. Nice to have you here.
Thank you, Isabel.
Yes, I have a quick question to start into our topic, which is currently the biggest obstacle preventing better use of surplus renewable energy.
Well, I think to answer that question, let's start with the reason why there is such a growing surplus, and it's clearly because there's a mismatch between when you have generation from renewable assets and the actual demand for energy. And this mismatch requires storage or flexibility from either side. Now, the obstacle for better use of this surplus as such is that we need to unlock further unlock storage assets and flexibility, which today is limited in the system. And to do this, we need to think beyond power to power. This requires sector integration, where you connect both power with heat and with transportation. The second obstacle, which goes in general for both flexible demand and storage, is that in some countries, we also see that the tariff structures, when it comes to the grid side, is still rewarding the old system with inflexibility.
Yeah, I totally agree. There's still a long way to go, but yeah, let's dive deeper into the topic. I'm very happy to hand over to you, Simon, and welcome again on behalf of the whole eWorld team.
Thank you, Isabel. Let me share my screen.
Yeah, Perfect.
Okay, so Euro's power surplus, a wasted opportunity. Well, let's start with how it looks and what is creating this surplus. So, if we are looking at the last decades, there's been a rapid investment, as all of us know, in intermittent renewable, primarily wind, and then solar has picked up over the last 5 to 10 years. And already in 2024 in Europe, renewable energy accounts for 49% of the total power generation. And if you then look at the intermittent renewable energy production from wind and solar and uncontrollable hydropower, the so-called variable renewable energy, VRE, it makes up a total 25% of all power generation in 2024. Now, this is for entire Europe. And then if you zoom in on the different countries, for example, in UK, this share of VRE is 34% or was 34% already in 2024, while in Spain, Germany, and the Netherlands, this share is as high as 43 to 45%. And this is where we stand today. What you see here is a graph looking towards 2030, which is the main case for Europe seen from IEA's a recent report on renewable energy. So with this expansion and of variable renewable energy, this leads to a continuous renewable energy surplus and an increasing curtailment of this power production. Now, what I showed here is from the same report. How is the curtailed energy and the curtailment rates of wind and solar in United Kingdom to the left and in Germany to the right? And what can be seen is that it's year by year and accelerating from 2020 onwards, is that you have an increasing share of curtailed energy. And the curtailment rates in the United Kingdom in 2024 for total VRE is almost 10%. Now, this is true in all markets where you see a rapid expansion and a big expansion of both wind and solar, such as Spain and Netherlands, to mention some of these. Now, the consequence of the expansion of VRE is also seen in the price formation in the markets. So with all this, with intermittent renewable energy production coming into the system, you see that the famous duck curve is both getting deeper and wider. What you see here is the development in the day-ahead market in Germany for the period 2021 to 2024. On the left-hand side, you have the normalized average hourly prices for Germany throughout 24 hours for the full year. And it's what you can see is that from blue line in 2021 all the way to the red line in 2024, you see that the curve is getting deeper and deeper. And this is going hand in hand with the renewable variable renewable expansion. And then if you look on the right hand side and zooming in on the month of April to September, where you also see the effect of this increasing share of solar PV, where you see an even steeper or deeper duck curve. So both in terms of that it gets deeper midday, but you also see a development that it gets wider over the day. And now I'm showing you here the figures for Germany, but also as another example, we can look at Spain. And in Spain, you see the same depth, but you see an even wider curve especially on midday, which is because of the share of solar PV that is being introduced to the system. So then to the question, is this a wasted opportunity? Until today, and still, when we talk about storage and flexibility introduction to the system, we are talking about mainly power to power. And then we're talking about battery, electrochemical battery, BESS. While BESS is and will have an important role in the future, today's and in future energy system and power market, what you see is that you also need longer duration storage. So BESS, typically you're talking up to 6 hour EP ratio or duration of the storage, but to match the inflexibility and the caused by wind and solar, you need also longer duration storage. And if you look at unlocking this storage, you need to look beyond the power market only. Now, this is a famous slide and a famous picture used widely, so I'm sure most of you recognize it. But it's very demonstrative for how the total energy system actually looks like. So if you look at the global final energy use, electricity actually accounts for only 23%. Transport accounts for 28%, while heat accounts for almost 50% of the global final energy use. So when we're talking about really introducing and utilizing or unlocking the potential that this surplus gives in terms of new flexible solutions and energy storage, we need to look beyond electricity and the power market. And what I will dive into today and give you an example on today is within heat. Now, as you saw, heat accounts for almost half of the total final energy consumption, roughly 49%. And if you break this heat demand, this energy demand further down, you can separate between industrial processes, buildings, and agriculture. And industrial processes accounts for 55% of this heat demand, while roughly 42% goes to heating of buildings, and then the remainder for agriculture. And all these heat and energy demand in form of heat accounts for 30% of all energy-related CO2 emissions in 2024. So when we look at the green shift and the decarbonization of societies, the key lies in heat. Now, when you look at heat production, there are different solutions to it, dependent on the temperature. Now, direct electrification is suitable for lower to medium temperature heat. That is in residential heating, where you have a big build out and of the very efficient heat pumps. While if you go into the industrial sector, where you have higher temperature heat, so heat between 150 to 500 degrees, this is where you see energy storage, and then first and foremost thermal energy storage comes into play. Then for the very high temperature heat demand, typically in some steel and aluminum production, you have a place for hydrogen and ammonia solutions. What I will focus on today is the industrial heat in the low to medium temperature range. And just to give you an insight into how a thermal energy storage setup works for doing power to heat for the industry. Here you have a heat cube, which is the product that we in Kyoto is providing for the industry. Heat cube is a modular setup. Simply explained, it comprises three parts. One is a heater that we connect to the grid, which transfer power into and use electricity from the grid or from an off-grid asset, and store energy from the grid in form of heat in storage tanks. Then the last part, which is the steam generator or heat generator, there we take the stored energy and we produce energy as it's needed in the industry in form of, first and foremost, steam, but industrial heat in the temperature range up to 400 to 500 degrees. Now, as I said, it's important in that these products has modularity, because the industry varies in size and in need, and also the power markets in the various countries varies in terms of how the as I said with the duck curve, how deep is the duck curve, how wide is the duck curve, and how is the overall power markets in a certain region. That's why our solution with the heat cube is a modular setup where we can size both the storage, the electrical charging, and the heat discharge in accordance with the need for the specific industry and the market we're operating in. And an important aspect of thermal energy storage when you do power to heat that separates from power to power is that the charging side, where you use electricity, and the discharging side, where you produce heat, they are disconnected, which allows a thermal energy storage asset like the heat cube to do simultaneous charge and discharge. Now, if we look at electrifying industrial heat with thermal energy storage, what numbers are we talking about? How big is this demand and market? So if we take the mid-temperature heat market potential globally, we're looking at a stunning total of more than 11,000 terawatt hours that today is being produced with fossil fuels and is ready for electrification. Now, this is spread across the world, and if you look at Europe alone, it's roughly 1,500 terawatt hours of heat needed in industrial processes. And if we are electrifying this industrial heat demand with thermal energy storage, this is representing worldwide over 4 terawatt or 4,000 gigawatt of new flexible power demand. And this is because a thermal energy storage asset doing power to heat has a longer duration storage. So typically it would be sized that you charge around 8 hours per day while providing heat 24 hours per day. And that represents 16 hours of storage duration. So what you're doing here is sector integration. You are electrifying the industry, decarbonizing the one biggest contributor to the CO2 emission, while at the same time we are solving the challenge of flexibility in the energy system. Now, how does this work? So with thermal energy storage doing power to heat, like our product, the heat cube, we are providing heat to the industry when they need it. And the industry typically has energy demand 24 hours per day. We deliver this heat to the industry while sourcing electricity from the grid or from off-grid assets whenever it's available, whenever the renewable energy is available and the power prices are low. And if you look at the storage duration we have here, typically we would configure our heat cube so that it needs to charge between 6 to 10 hours per day, which corresponds with the hours where you have a surplus from renewable wind and solar power in the market. At the same time, these assets are very responsive. So not only sourcing energy from the primary power from the primary market, the ahead market, but also providing ancillary service throughout the various balancing markets on an ongoing basis throughout the operational days. So while thermal energy storage with power to heat is a solution to decarbonize industry, it's providing additional service to power markets and to the grid operation. So basically what you're doing with the thermal energy storage asset doing power to heat is that you are providing load shifting. So they're matching the load in the market and on the grid with when you have surplus power. This allows for not only utilizing the surplus that we already see in the market, but also further renewable energy integration into the market that is necessary for us to fully decarbonize not only the power market, but the energy system as a whole. And what we're doing now is that we are providing sector coupling, which, as if we go back to one of my first slide, looking at where is the energy demand in the total global system, well, it's in both heat and transport, and therefore we need to couple the sectors to enable the full use and opportunity of renewable energy. And at the same time, as you're introducing long duration storage, and it provides a lot of flexibility to balance out the grid. Now, thermal energy storage is a solution that is available and proven today. We in Kyoto, we have already installed 2 heat cubes. One is placed in Aalborg in Denmark. This is our first installation, a commercial pilot with a charging capacity of 5 megawatt, a storage capacity of 18 megawatt, and a discharge capacity of 4 megawatt. With this asset, it's proven that the heat cube and thermal energy storage can participate across all balancing markets and follow the day ahead and intraday wholesale markets in terms of the available and surplus power. Then we have a second heat cube in Hungary, and this heat cube is a fully commercial asset installed at the food ingredients producer Kall, which use a lot of steam in their process. This asset has a charging capacity of 10 megawatts, a storage capacity of 56 megawatt hours, and a discharge capacity of 7 megawatt. This asset we inaugurated a few weeks ago, and both of these assets are now proving not only the technological side, but also the commercial side of thermal energy storage in power to heat. So power to heat with TESS is a solution ready and available today, and it's a way of utilizing the power surplus that we already have in the markets today. Now, when introducing new products, but also building new markets like the heat market, which is in the very emerging state, the green heat market, we see that the customers and the industry wants a solution that is plug and play and that helps them to navigate in the risk and uncertainty in energy markets. That's why we have our main offering, which is heat as a service, where we offer a low risk, cost effective solution to decarbonize the industry's process heat demand without the need for major capital investment or operational disruption at the customer side. So with heat as a service, we are providing green steam at a predictable and competitive price to today's fossil-based solution. And this without no technology investment, no installation and maintenance, and no operational and market risks. So thermal energy storage with doing in power to heat is a solution that is available technically. It's proven also now commercially, and it's a way to utilize the surplus power that we already have in the system. Thank you. That was what I had prepared.
Yes, thank you so much for the overview. That's great. So we can directly jump into the Q&A sessions. If there are any questions from the public, now it's the right time. I will have a look in the Q&A tool. Maybe a question to start with. You mentioned all the advantages of the thermal energy storage solution. What do you think are hurdles in using this technology?
Well, I think, of course, looking at recent years, so the heat market in general and electrification of heat market is an emerging market and in a very early stage market. So it's over the last couple of years, it's been a lot about awareness around power to heat, which we are now seeing is being picked up on, and that of course goes hand in hand with not only us but also our competitors in the market, or all the solution providers that are bringing and verifying the technology side of it, but also the commercial side of it. So I think to date it's been about creating awareness and taking away the risk in terms of that this is a new market with new solution.
Okay, I can understand. So people are more focused on the electricity side and not on the heat side. Okay, yeah. So we have a question in the chat. You need an installation pretty close to the demand side, but you said there's no installation. Can you maybe clarify
Okay,
that?
yeah, that I can clarify. So of course, what you do is that you go and install the asset at the industrial site. So today, the industry that uses heat, they already have typically a gas boiler. If you're producing steam and you're using steam in your process, you have a gas boiler, perhaps two gas boiler at the site. So what we are doing is that we are going in with a limited footprint into the site. We are installing the heat cube at the site. What I meant with no installation is that we take under our heat as a service offering, we take care of the installation and the operation of the asset. We connect to their heat infrastructure at site, and then we deliver steam, so that there's limited interruption into their process. Typically, the industry, their core process is not the energy demand that they have. They need a lot of energy, but their core process and technology is attached to whatever product they are producing. And so what we are doing, we are going in, we are decarbonizing their heat demand at a lower cost than their current solution, which is fossil based. But we take care of the installation and operation of the assets, so that they only pay for the green heat they receive.
Mm-hmm. Can you estimate how long approximately it does take to implement the storage system? I think it depends also on the size, but
It
is
depends
it
a
a
bit
week
on of
or
course on
a
the
month?
project and
Yeah.
also the conditions at the site. But typically we are looking at between 9 and 15 months
Okay.
from, and this is mainly due to that you also need the permits in place, and you are also often connecting to the grid site, so there are some time sensitive aspects tied to that.
Okay. Mhm. Another question is focusing on the duration of the storage. So how many hours can the uh, storage be used for?
Yes. So typically, it depends a bit on the demand and the demand curve that an industrial site has. Typically, the industry needs heat 24 hours a day or 24/7. What we do then is that we configure our thermal energy storage solution, the heat cube, so that we ensure delivering heat whenever it's needed. So for example, on 24-hour basis. And then we also size it towards the market we're in. So for example, if we are in Germany, where you have a bit steeper duck curve or price formation in the market, so you have less hour but very low prices, we target, we size the charging, which then determines how many hours we need to charge to deliver the energy in form of heat over the 24-hour basis, dependent on the market. And this can vary a bit from market to market, because in some markets, like in Spain, for example, where you have a deep period in the midday with low prices, but it's also wider because of the system. So that then it requires that we configure the size of storage versus charging to charge a few hours more per day. But typically we are looking at between 8 to 12 hours per day of charging. So that means that if we are charging the heat cube 8 hours per day, and we're delivering heat 24 hours per day, then we have storage for the 16 hours when we are not charging.
Okay, thank you. Another question, can you please provide some comparative capex indicators for a typical industrial complex? Do you have an idea?
If I understand, could you repeat the question, please, Isabel?
Yes, could you please provide some comparative capex indicators for a typical industrial complex?
Yes. So I think, of course, I am not able to go out with capex numbers on our products. But what I can tell from that point of view is that, and what is important is that our solution is competitive with the alternatives. And if you look at the reference today, which is fossil based, and first and foremost, it's natural gas that is being used to produce industrial heat. So what a product like the heat cube, to be cost competitive, you need to be able to provide heat at a lower cost than the current solution, and that we do with good profitability. So our long levelized cost of heat is lower than the reference solution. Then, of course, you have, and it's been talked about, how about putting an e-boiler, electrical boiler in, and you combine it with the BESS. Now, that, I'm not going to leave numbers on that, but if you look at the capex of battery energy storage and how you would need to size that to be able to operate with the same flexibility, it's quite easy to say that the cost of such system, a combination of e-boiler and BESS, is not compatible, and it's not going to be profitable when you're doing power to heat.
Mm-hmm. Yeah. Thank you. Before you mentioned the permits in the installation process, so how is your experience with permits for the electricity grid access? I think it's sometimes not that easy.
Yes, in general, I think this is one of the biggest challenges we stand in front, or the challenges we have in general when it comes to electrification, and that is the grid. Now, the advantage of flexibility or let's say solution within decarbonization and electrification that provides flexibility to the system is that you're able to enter into conditional grid connection agreements, because what you're doing when you are utilizing the low cost of renewable power is that you're also using the grid in the hours when you have a surplus of renewable power, and you're staying away from the hours where you, from a historical perspective, typically early morning and in the afternoon and late night, where you have the peak load. And so even though you have, of course, even for us, the grid constraints, they are present. But even though you have grid constraints, as you have the flexibility in which hours you charge from the grid, you're able to enter into conditional grid connections where you stay away from the peak load hours on the grid. And this speeds up, in our experience, the process towards the DSO and the grid operators.
Thank you. So I see maybe one more last question. In which countries in Europe do you think the thermal energy storage most likely to develop fast in the future?
Well, I think right now, of course, if you look at the industrial side of it, you have industry across entire Europe, and there's a heat demand across entire Europe. What is determining which market that is going to see fastest or most deployment of thermal energy storage and therefore electrification of this industrial heat is in the market, of course, where you have the right poor market conditions, meaning that you have sufficient volatility in the market and renewables integrated into the energy system. This is also something we have across most of Europe, but in some countries you have more than in others. And if we look from a poor market perspective, right now it's Central Western Europe with Germany, Netherlands in the lead. And then you also have in Southern Europe, in Iberia, especially with Spain, that is very attractive from a power market point of view, looking into fuel switching. Then, of course, you see in an important aspect is how far is the various countries in terms of facilitating and incentivizing all kind of storage, but new flexible demand into the system. And there you have, I need to mention Spain, where they have transitioned the grid tariff scheme to be from a static to 100% dynamic. So in the tariff scheme alone itself, you are paying based on which hour of the day, which day of the week, and which month of the year, which are actually incentivizing flexibility, and it's very what you say, a very supportive condition for doing fuel switching with thermal energy storage. Yeah.
Okay, yeah, that sounds like a good approach. When you provide the heat cubes as a service, do you come with containers which could be set up quickly?
So our HeatCube is a modular product with the modules. We have storage modules, we have charging modules, and we have discharging modules. And dependent on the configuration needed on each side, we set together. You can look at it as a set of Lego, right? So you have different pieces that you set together. These pieces are standardized, so to reduce and limit the time needed to install the product at site. Yeah.
Okay. Thank you. I think you answered all the questions which came up in the chat. That's perfect. If there are any more questions arising afterwards, for sure, you can reach Simon afterwards. You will find his contact details in the presentation, which I will upload on the event page. So with that, thanks again, Simon, for being here today, for giving us all these interesting insights. And yeah, we are all very curious to see how the whole storage market will develop in the future. And yeah, you can also look forward to discussions on that topic during next eWorld in February. And you can, yeah, stay tuned for the new program, which will be published in November. So quite soon.
Thank you, Isabel.
And yes, I just have some more announcements, because a further topic which is hotly discussed in the energy sector is AI, and this is why we are talking also about this topic in our new webinar series. It's called AI Meets Energy: From Potential to Practice, and it will take place from November 10 to 14. So a hot recommendation for you all to join us, to sign in, and it would be really a pleasure to welcome you again then. So yes, thank you for the moment, and I wish you a great afternoon.